So the first question will be question 6.47. Question states here, determine the force in members EF, EP, and LK of the Baltimore Bridge Truss and state if the members are in tension or compression. Also indicate all zero force members. And this is a schematic diagram of the system. And to solve this question, we have to fulfill 3 tasks. The first will be find force in members EF, EP, and LK. Secondly, state these members are in tension or compression. Thirdly, indicate all zero force members. In this diagram, actually we have to eliminate the zero force member. And which of these members are actually zero force member? We can see here. Actually, N, B, and C, O, C, O, D, J, G, JH are the zero force member. And in here we have 2 support member, which is one is the smooth pin, one is the roller. At smooth pin, we have 2 support reaction, which is AX and AY. At roller, we have support reaction IY. Okay. In chapter trusses, we always assume all members in tension. So if in tension, the force direction will pointing upwards. And if in compression, the force direction will pointing inwards. Okay, we have to understand this first. So we continue to our question. As I said just now, we have 3 unknown here, AX, AY, and IY. So actually we have to solve it out first before we continue to our further step. We will start with our summation of Fx. Summation of Fx equals to 0, and also summation of Fy equals to 0. And in summation of Fx equals to 0, along x-axis we have only Ax. So Ax will be 0. In summation of y, along y-axis we have both Ay and Iy force. So Ay plus Iy force equals to 0. An equation with 2 unknown, we couldn't solve. So we have to proceed to third equation. Summation of m at a certain point equals to 0. So in here we choose point A. Why should we choose point A? Because point A compared with point I, it has more force on it. So we choose point A. So moment, the equation for moment is force times with the displacement. Okay, remember, if the motion along the clockwise, it will be negative. If motion along counterclockwise, it will be positive. So let's see here. Summation of MA equals to 0. We have who? We have force C times with distance, force E times with distance, force F times with distance, force G times with distance, and force Iy times with distance. Remember the positive negative sign. So FC to point A, it turns clockwise, so it will be negative. FE to point A, it also turns clockwise, so it will be negative sign. FF is the same too. To point A, turn clockwise, it will have negative sign. Force of G, it also turn clockwise, it will get negative sign. And for force IY, it actually turns clockwise. Counterclockwise, so it will have positive sign. So we sub in the value, do the maths, and we will solve. We will get negative 102 plus 16 FIY. So FIY equals to 102 divided by 16, and we will get 6.375 kilonewton. After we solve for force at IY, we can proceed to our question, which is finding the force in member EF, EP, and LK. So continue our question. Always start with summation of Fx equals to 0, only followed by summation of Fy equals to 0, summation of moment equals to 0. So we start with summation of Fx equals to 0. In Fx, we have the value of, before that, to solve the member force in EF, EP, and LK, we have to cut this system into segments. So where should we cut? We should cut here, cut here, cut here, cut here, or where? So actually we will choose cutting at the common point or common place that touches three force member, which is EF, AP, and LK. So you will cut at here. Okay. So we continue. We will do the summation of Fx first. So summation of Fx, actually we have to resolve the point at point P. We have to resolve into summation. We have to resolve into force of X and force of Y. And because the force PE is actually slanting, so we have an angle here, and the value for the angle you see here is 2, here is also 2, so it will be right angle triangle. So here will be 45 degree, 45 degree here, and also 45 degree here. So we continue. Summation of Fx, we have along x-axis we have force of PE of sine 45. Why it is sine 45? Because we place the 45 angle at here, so opposite it will be sine 45. And continue with minus FLK minus FEF. Okay, with three unknown we cannot solve, so we proceed to summation of Fy equals to 0. So summation of Fy equals to 0, we have along y-axis we have summation of Fy, we have a force of F, force of G, force of Iy, and also force of PE times with cos angle. So the direction is pointing upwards is positive, so in opposite direction it will be negative sign. So force of P, force of F will be minus 3, force of G will be minus 2, force of Iy will be positive 6.375, and force of PE will be minus, because in opposite direction, minus PE cos 45 equals to 0. So with one unknown we can solve, and we will get force of PE actually equals to 1.9445 kilonewton. As I mentioned just now, tension, the direction of force will pointing upwards, so our force of PE pointing upwards. So the assumption of force of PE pointing upwards will be correct, so it will be tension. Remember to write in bracket tension, as the question asks you to state whether the member is in tension or compression. So PE done. So we see back to summation of Fx. Can we solve summation of Fx? No, because we still have two unknown. So we have to proceed to summation of moment. Summation of moment, we should choose which point? E, F, G, H, I. Remember, as we said just now, we should choose the point which has the most number of force, which is at point E. We have force of LE, force of PE, force of FE. So it has the most number of force. So we choose moment of at point E. The same thing, the equation for moment is force times with distance. And remember, to assume that any direction to the counterclockwise will be positive, and in opposite direction to the clockwise will be negative. So F, force of F times with distance will be 2. It turns clockwise, so it will be negative. So force of G, it turns clockwise, it will be negative. Force of I, it turns counterclockwise, so it will be positive. And also, don't forget our force of LK. We normally assume that the direction will be pointing outwards, as we say that all members supposedly at first assume that it is direction pointing outwards. So we put pointing outwards, so it turns counterclockwise too. So you will get positive FLK times with the distance, which is 4. After that, do your maths and you will get force of LK actually is equal to negative 9.25 kilonewton. And in here, it is negative 9.25 kilonewton. So the assumption of the direction for force of LK is actually wrong. It is not tension, but instead, in fact, it is force LK is supposedly will be compression. So the direction will be like this. Okay? So we proceed with the value of force of LK, value of force of PE. We can solve for force of FE already. So force of PE we get from the summation of Fy will be 1.94445 sin 45. Force of LK is also the same. From the summation of ME, we will get negative 9.25 and minus F, force of Fe. And you do your maths and you'll get, actually you'll get force of Fe will be positive 7.875 kilonewton. So positive, remember state whether it's compression or tension. So if positive, it will be tension. Okay? So that's it for question 6.47. Thank you. So for our second question will be question 8.48. The question states here, the big AB has a negligible mass and thickness and is subjected to a force of 200 Newton. It is supported at one end by a pin, and at the other end by a spool. This is actually a spool having a mass of 40 kg, which means this spool have a mass of 40 kg times with gravitational acceleration. And question continues to say that if a cable is wrapped around the inner core of the spool, which means this P wrapped inside the inner core, and determine the minimum cable, which is this cable, force P needed to move the spool, which means pull the spool to have a motion towards right. Okay, so the coefficient of static friction at B and D are mu B equals to 0.4 and mu D equals to 0.2 respectively. So the question given, we have two mu B equals to 0.4, mu D equals to 0.2, which means we have two frictional force at point B and point D respectively. Okay, so in here we can see that we have two objects. One is the bar, one is the spool. Okay, so in here we have to understand two things. To do further calculation for this type of question, we have to separate these two objects into two free body diagrams, and also if object of the bar and object of this spool in contact with each other, we have the normal force, which I will show it to you later. And also if an object in contact with a surface, it also have a normal force, which I also will show you later. So we proceed to our calculation. First, we will do the free body diagram for this bar. Okay, so here will be free body diagram for the bar, and question state that this is actually a support member, smooth pin, and we will have two support reaction, which AX and AY. And remember, an object in contact with another object, we have normal force. Always assume that your normal force is pointing upwards first. Okay, so to solve this free body diagram, to find the value of NB, normal force B, we have to do the same thing like usual. Do summation of Fx equals to 0, summation of Fy equals to 0, and summation of M equals to 0. So Fx equals to 0. Along x-axis, we have Ax equals to 0. So summation of Fy equals to 0. Along y-axis, we have Ay and NB. An equation with two unknown we could not solve. So we have to proceed to the third equation, summation of moment at a certain point equals to 0. So which point should we choose? A or B? For sure we will choose point A, because point A has the most number of forces, okay, compared to point B. So if you choose point A as our moment okay, and also remember, if the direction turn clockwise, it will be negative. Direction turn counterclockwise, it will be positive. So we elaborate our equation. Force time with distance. So it turns clockwise, which brings this negative sign. And NB, time with distance, it turns counterclockwise, so it will have positive sign. Counterclockwise, so it will have positive sign. Do the maths and you will get normal force at point B actually will have the value of 133.33 Newton. Okay, that's it. Remember this value. So we proceed to the second free body diagram, which is this spool. Okay, so for the second free body diagram, let us see. Just now we state that the normal force at the bar is actually pointing upwards, right? And how come? What's the reason for this normal force at point B pointing in opposite direction compared to the bar? Because in a system, in a body, we have to balance up our normal force. So one pointing up, one pointing down. If let's say we give a simple value 3, and this is 3, and we will get 3 minus 3 equals to 0. So balance out, it cancel off. Okay, so just now we have NB as 133.33. So if in opposite direction, we actually add one negative to show that it is opposite direction. So we actually draw this in opposite direction, so we can ignore this negative sign, as we already shown that the direction is in opposite direction. Okay, so remember just now the question we said that it got two frictional force, which is one at point B here and point D here. So remember to draw your frictional force direction. And why? How come your frictional force direction is pointing towards the left? Because when you use your force, pulling force, to move your spool to turn in the motion to the right, your frictional force will to the left. Okay, understand? And also remember just now we said that an object in contact with surface, you will have normal force. So we have normal force D. And remember your weight, your force weight. Okay. Okay, so we do our equation like usual. We use summation of Fx equals to 0, summation of Fy equals to 0, summation of M equals to 0. So we solve first. So for summation of Fx equals to 0, we have along x-axis we have force of P. Assume all direction to the right side will be positive, okay? So we have force of P minus frictional force of point B and frictional force at point D equals to 0. 3 unknown we could not solve, so we proceed to summation of Fy equals to 0. So summation of Fy equals to 0, assume direction pointing upwards will be positive, and we have along y-axis we have ND minus NB minus weight. So sub in your value for NB 133.33, sub in your value mg 40 times 90, mg 40 times 9.81, and you do your maths and you'll get normal force at point D equals to 525.73. So let's see back the summation of Fx. Still we have 3 unknown we cannot solve, so we proceed to summation of moment. So summation of moment, you actually can choose whether you want to do your summation of moment at point B. So as I mentioned just now, either we can choose at point B or point D to find the moment. So first we choose moment at point B. We use try and error method, okay? So summation of point B equals to 0, and also remember direction, if turn counterclockwise will be positive, clockwise will be negative. Moment, the equation will be force times distance. The distance should be perpendicular to the force. And let's see. In the diagram, we have force of P times with distance. So force of P unknown times distance 0.1 plus 0.1, 0.2. So turn in counterclockwise, so positive. Minus force of frictional at point D, force of frictional at point D towards point B. So is clockwise, so be negative. And here is 0.3 plus 0.1, so 0.4. Okay? So with 2 unknown we cannot solve. But remember, the question given us the mu of D and also mu of B. So to find the frictional force at D, we actually use the equation mu D times normal force D. Mu D is actually 0.2 and normal force D here 525.73, sub in and we'll get 105 Newton. And with frictional force, to find the frictional force at point D, we already assume that spool spin at point D. Okay? And we sub in the equation, the value for frictional force at point D, and we'll get pulling force. Do the maths, and we get pulling force as 210 Newton. With this value of frictional force D and pulling force P, we can get force at frictional force at point B. Sub in the value, do the maths, and we get frictional force D actually is 105. To check whether the assumption spool spinning at point D is correct, we have to find maximum frictional force at point B. Okay? To check whether the value is more than or less than frictional force B. The formula is mu B times NB. Mu B is 0.4, NB from here 133.33, we get 53.33. Unfortunately, the maximum value of frictional force and frictional force at point B. So the assumption of spool spinning slipping at D is incorrect, and actually the slipping occurred at point B. So this assumption is dead wrong. So we have to redo again. Redo again the same thing. We use 3 equations. Summation fx equals 0, summation of fy equals 0, summation m equals 0. So summation of fx equals 0. We have the same thing. Frictional force, 2 frictional force, and pulling force. So pulling force minus by 2 frictional force equals 0. So 3 unknown we cannot solve. Proceed to summation of fy equals 0. So summation of fy equals 0. We have along y-axis we have nd, mb, fw, and we can do the maths and we can get nd. Okay, so we choose Just now we choose point D to do the moment. Now we choose point D to do the moment. So point D, frictional force at point D, ND, FW eliminate off already, and also NB eliminate off. So we left FP and FFB. So FFB, force times with the distance, 0.4, because this is turn A. Force times with the distance and force P times with the distance, and we will get this term counterclockwise, so it will be positive, and we will get this equation. And we just now assume that slip actually occur at point D. So now we assume slip actually occur at point B. So use the frictional force equation, mu B times MB, we get frictional force at point B is actually 53.33 Newton. So sub in and we get friction, after sub in frictional force, and we get FP, pulling force, is actually 107 Newton. So with these two values, we can sub into the equation summation of Fx, and we will get FFD equals to 53.67. So to check whether this assumption slipping occur at point B is correct, we have to find maximum frictional force at point D. Is mu D times ND, we get 105, and actually frictional force at point D, the maximum value is larger than frictional force at point D. So we can get the conclusion that the spool does not slip at point D. The assumption of spool slip at point B is correct. Thank you.